Students, in continuation to our previous class, we are now dealing a model related to potential energy graph. Remember, you have the graph. This is a graph taking u as a function of x. Now, in this, what is going to happen? You need to have some idea about the function. U can be given as 3 plus 3 sine. It is a function of x, some kx. You can also write this as 3 plus 3 sine. This k part, you can see that what is k actually. If it is a function like this part, whatever it is, if it is time, I would have written omega t. If it is length x, I would have written k. Remember, k refers to 2 pi by 1 length of the called as actually lambda. In this case, that lambda part is 2, means pi. Right, because you can't use the word periodicity here, omega term. Time, I would have written omega t. X, I would have written kx. It is like sine pi x graph. Right. If you don't want, if you just, no, it's like it's a sine pi x function otherwise, 3 sine pi x function. Now, what is f? F is minus du by dx. Minus of 0 plus 3 pi cos pi x. So f graph is 3 pi minus 3 pi cos pi x. That is the force function as x. What do you want? The maximum value of corresponding conservative force. Actually, here they're asking beta pi. In the place of beta pi, we have 3 pi. So the value of beta is 3 newtons. The easy question. Only thing that you need to know is the two things: drawing the function and relating that to f. It's a very simple question, basically. Right. We'll move on to the next question. The next question deals with a wedge with a circular track is fixed on the ground. The radius of the track is r. A small block of mass capital M is kept on the wedge as shown in the figure. Here C is the center of the circular track AB and X is the distance A along the positive x-axis from origin O. Coefficient of friction is a function of x. Mu naught, of course, is a positive constant. The work done by the external agent in bringing the block from A to B very slowly. Remember, very slowly. Very slowly attracts me. Why? Because I'll explain. Suppose this is the question, inclined plane based question. Yesterday class, I have just discussed this. If you are moving this block up, so work done by the friction is simply minus mu mgx. Here mu is constant throughout. And so we have written minus mu mgx. I told you, you can use this relation even for a curved path also, provided if it is slowly moved. Yesterday, here it is. Here it is. Here I have given you. Slowly moving up case. But the problem in this particular problem is mu is a function of x. So therefore, the total work done by friction is minus mu mg dx minus mu naught mg, which is a constant, x dx. Remember, x extends from 0 to r because this is x is equal to r. 0 to r. So finally, you have minus mu naught mg x dx is x square by 2, r square by 2. That is about the work done by the friction. What is the work done by gravity independent of path? Simply minus mgr. Because you have lifted the block from here over to here, that is a vertical, so mgr. No, now you apply work energy theorem. Work done by external agency plus work done by gravity plus work done by friction is delta Ke, which is 0. Work done by external agency minus mgr minus mu naught mg r square by 2 is 0. Work done by external agency is that's the picture. A very simple question. Uh, uh, you can expect that this model anytime in our weekend exams. See, when such a problem is given, I have identified the sources of different works. And at the end, I am using work energy theorem. Here, I have simply applied work energy theorem. Next. Now see here, you have one more question. Remember, in one word, I can answer this question. Even you can also do the same. In this question, if you notice, the particle is moved from one point to another point along two different paths, agreed. What is the nature of the force here? This is the nature of the force. What is the significance of this force? This is a uniform and constant force. I told you at the beginning, if it is a constant force and uniform and constant, means direction wise, magnitude wise, this is a conservative force. If it is conservative, work done is independent of path. So therefore, W1 is equal to W2. That's all. So my first identification factor is a uniform and constant. So it actually say uniform. Right. Next aspect, already we have done this model at the beginning of our classes. Remember, this is a previous IIT question also. I think you remember this. There are three forces involved. Smooth track is in the form of a quarter circle of radius 6 meters. Lies in a vertical plane. Particle moves from P1 to P2 under the action of three forces. Force F1 bar is always towards P2. I have done this question on my very first class itself. Always towards P2. and always magnitude 20 newtons in magnitude. I think I have derived this. In this case, always directed towards P2. Work done by that is root 2 FR. Actually, here it is F1, F1R. Root 2 F1R. So this is root 2 times 20 into 6. Right. F2 is always acting horizontally and is always 30 newtons. F2. Right. And F3 always acts tangentially to the track 15. See, work done by F2 is very simple. F2 times displacement. 30 times R, 180 joules. So work done by F2 is 180 joules. Correct. Work done by 3 is always tangential. F3 times length of the path. Even both I have done in my very first class. I'll show you that. F3 15 into pi into 6 by 2, 3. 45 pi joules. Remember, as far as F1 is concerned, it is always directed towards a point. Such a force is called central force. So usually central force means it is conservative because del bar cross F bar becomes 0 for this. So therefore, F1 is conservative in nature. F1 here 120 joules, which is wrong because we got 120 root 2 actually. All are in joules. So we have done this question long back. I just want to show you that. Yeah, here it is. I have done this question actually. And you have this proof also. You can see here. Proof. Please refer to this point. You may ask me then why you are repeating this question. This is a previous IIT question. See, potentially repeatable question for our weekend examination. Therefore, I wish you need to know this, how to solve this. Right. Actually, this comes under next week, but still, I would like to discuss this question. You can see the spring only here. The spring here, the right end is B, the left end is A. Since this end moves 2A speed, this end moves U speed. Suppose if by any chance the displacement of B is X, then the displacement of A will be 2X. Which clearly implies the elongation is 3X. Elongation is 3X. And that elongation you have given 6 centimeters. E is given as a 6 centimeters. Given. K is also given 10 Newton per centimeter. This is a 10 into 10 square Newton per meter. Right. So what is the energy stored in the spring? The energy stored in the spring is half of Ke square. Half of 10 cube times E square, 36 by 10 power 4. This is 1.8 joules. Hold on. See, please try to understand the rest of the question. The other end A is held by a man who is traveling on a trolley. All that is a different stuff towards left. At time t is equal to 0, the spring is relaxed. The man A pulls left with a constant velocity. All that is given. Whether you know the rest of the part or not is a different story. It's a multi-correct answer type question. In this option D, energy stored is 1.8. So what is the work done by the spring? It is exactly minus value of this. Minus 1.8 joules. So therefore, option D is absolutely correct. Next. Please try to understand whatever the energy it is shared in the form of 2:1. The work contributions 2:1 by A as well as by B. Why? Because you can see 2x and x. So work done by wall on the spring, 0.6 joules correct. Because if you split 1.8 joules into 2:1, this will become 0.6 joules. And this will become 1.2 joules. So work done by wall on the spring, 0.6 joules. Correct. Work done by man on the trolley from t is equal to 0. If this is positive, this is going to be the negative. Work done by man on the spring from t is equal to, 1.2 joules. Correct. All that is given here. The only funda that you need to understand here is, if this end moves by x and this end moves by 2x, clearly energy distribution or contributions will be in the same proportions. Next, the theory type question. You lift a book slowly from the ground and keep it on your study table. Choose the correct statements. The work done by you on the book is positive. You are lifting a book slowly from the ground and kept it on your study table. Imagine this is your study table. This is the book. You are lifting this onto the table like this. The work done by you on the book is positive, but force exerted by you on the book is a non-conservative. The work done by you independent of weight of the book, but dependent of path of the book. Wrong. The work done by you depends on height of the table from the ground, but independent of time taken by you in doing so. Yes, it is a time independent thing. Whether you do it for an year or in a second, work done is mgh. The total work done on book is non-zero, but work done by weight of the book is a negative. The total work done by the book is a non-zero, is a wrong statement. Why? I will explain. You slowly lifted. Work done by external agency plus work done by conservative force is change in KE. You said slowly, 0. So therefore, the net work done is 0. You said non-zero. So therefore, D is wrong. Again, the work done by you on the book is positive, but force exerted by you on the book is non-conservative. Actually, I should say that is wrong, because suppose if this is the free body diagram of the book, I'm just, okay, I am all the time applying a force equal in magnitude and opposite in direction to the weight. Since weight is constant, my force is also constant. If it is a constant force, it is a conservative. You said it is non-conservative. So therefore, I am taking this option as wrong. But if it is lifted by means of a string, tension force is non-conservative. Even actually muscle force is also non-conservative. But still, in this particular case, particularly the case A, since you are slowly lifting up, if your F and mg is always equal here, then obviously if it is a constant force, I can take it as a conservative force. Right. A carriage of mass m and length L is joined to the end of a slope as shown in the figure. Block of mass m is released from the slope from height h. Slides till the end of the carriage. You can see end means till here, till here. Coefficient of friction between the block and carrier is mu. Find the minimum h in the given terms. Now, what someone should understand is that it is a falling. Now, initially, it has some speed u. Initially, the carriage has zero velocity. Right. So, please try to understand this system has some momentum in the horizontal direction. So, initial momentum is this. Final momentum is this. This is called common velocity. Therefore, common velocity is mu by capital M plus small m. Right. Now, here, what is happening is there is an involvement of friction. Here, there is an involvement of friction. Right. This friction decelerates the first block, accelerates the second block. Now you do whatever, S relative must be less than or equal to L. That is the condition. Which clearly implies if I take V square minus U square is equal to 2AS. And by the way, what is A1 minus mu G? What is A2? Capital M. You take V square minus U square is equal to 2AS separately for the block. U square, sorry, final velocity is V square, VC square actually, minus U square is minus 2 mu G S1. Here, VC square minus 0 is 2 mu M1 by, M by small m by capital M G S2. Please hold on here. Please rewrite this properly. S1 is V common square U square minus V common square by 2 mu G. S2 is V common square by 2 mu G times capital M by small m. So S1 minus S2 must be less than or equal to L. That's the condition, which means U square minus VC square by 2 mu G minus VC square by 2 mu G times capital M by small m less than or equal to L. Actually, what is that they're asking is a mu only. Now you just solve this, you'll get the answer. This is one way of solving this question. If you go in center of mass, you can do the same problem in a much better way, actually. But it is too early, no? So therefore, I am just giving this up. I can write all that as I'll change the color. I'll change the color of my pen. 1 by 2 mu G, I will take common. U square minus VC square minus capital M by small m VC square less than or equal to L. So 1 by 2 mu G U square, U is nothing but root 2 GH. Root 2 GH. Minus VC square, common you can take. VC square means M square by capital M plus small m square. Again U square 2GH times 1 plus capital M by small m less than or equal to L. I think just you need to solve this. You'll get the desired answer for this. Right. Coefficient of friction between the block and the carriage is find the minimum value of H. You want H minimum. Just solve this. You'll get the required condition. You'll get option D as your answer for this. Next question. You are given F is equal to y square I cap plus x square j cap. Let me just find whether this is a conservative or non-conservative. Our standard formula is del bar cross F bar. So dou by dou x I cap, dou by dou y j cap, cross y square I cap, x square j cap. By doing which, you will have dou by dou x square k cap minus dou by dou y square k cap, which is nothing but 2 times x minus y k cap, which is not equal to 0. So F is a non-conservative force. Del bar cross F bar is not equal to 0. F is non-conservative. It depends on path. Now you take path 1 and path 2. Path 2, see path 2, you have this line as y is equal to 2x. Because it's a line that passes through 0, 0, 1, 2 passing through origin. Y is equal to 2x. Put x is equal to 1, y coordinate is 2. Now in this I have dy is equal to 2 dx also. From this f bar dot dr bar is literally y square dx plus x square dy. So substitute 4x square dx plus 2x square dx. 6x square dx. Now do the integration part. What are the limits? X is 0 to 1. 0 to 1. This will become 6 by 3, 2 joule. Path 2. Along path 1 is of two parts. O to A, y is equal to 0. So therefore, the integration part clearly, when y is equal to 0, work done is 0 in this part. Why? Any force if exists, it is perpendicular to x-axis. It is directed along j cap. You are moving along x-axis. Dot product is 0. Similarly, along A to P, x is equal to 1, dx is equal to 0, and y changes from 0 to 2. So dw becomes y square dx plus x square dy. Remember, the first part becomes 0. X square, x is always 1 here. So therefore, dy, and it is 0 to 2. So therefore, 2 joules. Please try to understand whether you go with path 1 or path 2, work done is 2 joules. Just because work done is the same along the two paths, don't come to a conclusion that the force is conservative force. Okay. My clear-cut observation is if del bar cross F bar is 0, force is conservative. If it is a non-zero, force is not conservative. That's all. And no other second opinion on this. Right. You take another model. Smooth vertical rod is released from rest such that it is constrained to move vertically on a smooth wedge. Theta is equal to 45. Theta is equal to 45, you have one constrained relation. Why? If the wedge moves right by x, the rod moves down by the same distance x. Theta is equal to 45. Wedge moves right by x, rod moves down by x, vertically down by x. What is happening? You have released. So the rod loses some potential energy. And this loss in potential energy is shared between the rod and the wedge as kinetic energy. When the wedge moves right by x, the rod moves down by x, vertically down by x. So loss in potential energy is gain in kinetic energy of rod and gain in kinetic energy of wedge. This is half mv square plus half mv square. Fortunately, why? Because mass of the rod and mass of the wedge is the same. So v square is gx and v is root gx. The speed of the rod is root gx, absolutely correct. Now please try to understand. See here, the contact force does work on the wedge. Like see, on the rod, suppose if there is some Ny, for example. And on the wedge, if there is some nx, since it is 45, for theta is equal to 45, nx is same as ny. The contact force components. Therefore, what is the work done on wedge? Simply change in kinetic energy of mv square, which is mgx by 2. So therefore, work done on the rod is negative of this. Because internal forces, net work done by internal forces is 0. So therefore, if that is plus mgx by 2, it is minus mgx by 2. B correct, C correct. So work done by contact force on the rod 0 is wrong. When I have accepted C, or when I have accepted B, how come D correct? Here, this rule is applicable only when theta is equal to 45. Otherwise, nx becomes n sine theta, ny becomes n cos theta. Since it is 45 degrees, I have taken that nx is same as ny. A very, 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 very good question actually. Now let us work on this question. Let us work on this question. Now, in this case, a thin rod of mass m, which is confined to move only in the vertical direction, is placed on a wedge of same mass m. The wedge and a hemispherical cutoff of radius r, and initially the rod is just under the upper rim of the hemisphere. Okay. Now the system is released from rest actually, and all the contact surfaces are smooth. Please try to understand. This is a multi-conceptual question. Actually, it is favored when linear momentum conservation is known to you. Not necessarily that they might give you question this time, but the problem is I want to discuss the question right now here only.